Ahoy there shipmates, and welcome to another video brought to you by the 5-Minute Mariner. My name is Nicola and I am one of the content creators here at the 5-Minute Mariner, and in today's video we will be discussing how a submarine is able to go underwater. To first understand how a submarine dives, we must discuss buoyancy and why it floats. When an object, such as a ship, is placed in water, its weight pushes down into the water. Weight is a force that acts directly downwards and is based upon the mass of the object. When this happens, another force opposes the weight of the ship and pushes directly upwards. This force is called buoyancy and is the reason why ships not only float but why they sink. The size of the buoyancy force depends upon the physical shape of the object being placed in the water, as well as the mass and density of the object. So let's take 3 examples. In the first example, the weight of the ship is smaller than the buoyancy force. This means the ship is positively buoyant and so it will float. In the second example, the weight of the ship is the same as the buoyancy force. This means the ship is neutrally buoyant and will also float. In the final example, the weight of the ship is more than the buoyancy force. This means the ship is negatively buoyant and so will sink. The difference between a ship and a submarine is that a submarine is able to change its weight and hence can change from floating by being positively or neutrally buoyant to becoming negatively buoyant, allowing it to submerge. So how does a submarine change its weight? The answer is by allowing water into large internal tanks called main ballast tanks. The design of a main ballast tank is fairly simple in that it has a free flood space that can either contain air or water. When it contains air, the submarine's buoyancy remains positive or neutral and hence it will float. When the tank is filled with water, the submarine's weight increases dramatically, causing its buoyancy to become negative and hence it sinks. The operation of a main ballast tank is as follows. Air vents at the top of the tank are opened, which causes the air inside the tank to vent out of the top. At the bottom of the tank is an opening which allows water to move inside the tank, thus increasing the weight. Modern submarines have numerous main ballast tanks located all along the hull, which allow a large amount of water to be stored, which dramatically increases the weight of the submarine by several tons. So let's recap. A submarine on the surface has a positive or neutral buoyancy, which means the weight of the submarine is less than or equal to the buoyancy force. To submerge, main ballast tanks are vented, which forces the air out of the top and allows large amounts of water to enter the tanks, thus increasing the overall weight of the submarine by several tons. The increase in weight changes the overall buoyancy of the submarine, so it is now negative. The submarine will now begin to submerge, and in addition to the negative buoyancy, the submarine will use its propulsion and control surfaces to drive itself underwater. This is quite a remarkable feat when you consider that modern submarines can submerge in only a few minutes. Thank you for watching, and don't forget to like, comment and subscribe for more content.